Hi everyone, this is Francisco Contreras. I am recording this video um, mainly to share some ideas that I had. Um, I think the first one was it's regarding space. Okay, so I was thinking about these black holes. Okay, there's black holes out there in space, and I was thinking that black holes are moving around. And from what I understood, by watching other videos on YouTube, these black holes go and they absorb, they suck in, basically they're swallowing other planets. And I was thinking maybe they're just having sex. Planets having sex. Like humans have sex, animals have sex, everything has sex. Or that, or it's a black hole is cleaning up space, you know, outer space. It's cleaning it. The best way that I can describe this is um the best way I can describe this is fucking goddamn. The best way I can describe this is oh, because through the YouTube videos that I've been watching, no one ever made it this clear to me. Basically a black hole. Um, black holes. They suck in, things that are out there in space, gases, dust, and stuff like that. Okay, so there's gases and dust particles, basically, um, in outer space. Okay, and maybe there's more stuff here. About 15% of the visible matter in the galaxy is in the form of gas and dust, serving as the raw mineral for new stars. Basically, um, there's a bunch of gases and dust. Kind of like when we go outside and there's a bunch of dust everywhere. Okay, and then it just so happens that, with the right composition or whatever, maybe a star and Earth can be created out of that. I'm not sure. Serving as the raw mineral for new stars, about 99% of this interstellar matter is in the form of gas. Individual atoms or molecules, the most abundant element in the interstellar gas are hydrogen and helium. Okay, so that's why I looked up this water level thing, because we know scientifically that water always will always be below the oil. Oil will always float to the top. Okay, and then there's even air levels, um like graph. Let's look at a graph. Okay, right here I think let me go back. I think I seen something right here. Um yeah, I don't know what this is. Air level. Maybe I should select or look for different types of different types of different types of gases in the air, and like a graph. Okay, so I mean, I kind of wanted more like something like this. So we have right here. It looks like we have and this is so weird. Hydrogen, oxygen, argon, carbon, alloy, something, water, vapor. Is that water? Water, vapor, trace elements, I think. Percentage in Earth's atmosphere. So, anyways, I wanted to technically talk about this. Yeah, right here, look at nitrogen, oxygen, argon, carbon dioxide, minute traces of neon, helium, methane, water vapor, krypton, hydrogen, hexagon, and ozone. Okay, so technically, um, I mean, according to this, there's a bunch of gases and dust. Okay, so when someone is describing a black hole and it's traveling through space and it's sucking up planets or sucking up um, like clouds of dust, it's kind of like um, the lights, the colorful lights, the aurora lights. It's kind of like that because it's like some type of chemical or gases in the air. I'm thinking um, that cause that to happen. So when we look at images from space, it looks like there's like this aurora type of you know phenomenon occurring, and these images, when they're taken, and obviously when they're shared to us, I'm just trying to point out that when they are shared with us, they look super astonishing, like super badass. Like they're definitely out of this world. They are just amazing things to just look at, and I could just imagine how they would look like in real life. Because personally, I never got to look at the Northern Lights other than like on YouTube, the internet, or in some rare cases like in movies, through movies and stuff like that. But in real life, I never had the opportunity, the chance, the privilege to go and look at them and witness them, with my own eyes, on site type of thing. So, I'm sure it's the same thing when this stuff is um, getting sent back to the ISS or whatever. These images, this data, it must be super, super cool for the astronauts and other people who are up there, living in the ISS or just visiting. Um, but I never knew that um, a black hole was technically sucking this stuff up, like other planets and stuff, like in that way. So I instantly thought, well, maybe these black holes are cleaning space. Maybe they're only swallowing up certain planets that are it can that could be a possible contamination or something like that. Um, and then when we look at it with the water level thing, um, I'm thinking that because I seen a graph where after where the gravitational pull um, is basically pulled um, is pulled downwards um, to a point where no light can escape. Um, After all, if light cannot escape from the meaning they do not emit light or reflect light, how can we see them? Black holes. Let me see. Okay, so something like this. They call it the black hole, and then there's the event horizon. I think after that layer, so think about it like water layers. There's a bunch of. I mean, this is a bad example because it's only like a little bit of layers, but there's some graphs where they show a lot of layers of stuff. Look at this. There's 3 layers here. There's oil, emulsion, whatever that is, and then there's water. Okay. Um, so right here we have water, transistor zone, oil, and then we have gases. Okay, so there's different levels. So going back to this graph here of the event horizon, there must be some type of um, other type of layering that should make sense to us all, just like we all understand that water will always be at the bottom of a cup, and the oil will rise to the very top. Um, um, and then because I remember looking at a documentary video where there's salts, like salt, like in the ocean, salt, water, but then there is another salt layer that is more acidic. Um, and then let's just look at that and let's try to look for some images. So, okay, let's look at this right here. So, I don't know, there's a chemical reaction. I don't know, this one's not good. Water-rich phase. Look at this, there's an organic layer. Aqueous layer, I'm sorry. So there's a bunch of layers, but I was looking for, it's like deep down in the ocean, super deep in the ocean, that if certain fish actually swim down there and have contact with this water, it's like poison to them and they will die. I just forgot, um, like what type of salt or whatever this might be, but I'm thinking it's ammonia. Like, well, maybe. I'm just guessing here. But there is another layer saltier than salt water, and it goes all the way down. Um, what is heavier, salt water or um, ammonia? Um, when is it toxic? Ammonia levels in fish tanks. Ammonia, nitrite, nitrite. There's freshwater ammonia. Yeah, this is not very clear. Like, I know what I'm, trying to share, and I know exactly what I'm, you know, like talking about, but I can't find what it is I'm trying to illustrate to all of you. Um, let me see here. Saltwater, like in the ocean, in the in the ocean, ocean, saltier layers. Let me just type this. Let me search for this. See what happens. Okay, so mm, low salinity surface, mixed layer. Oh yeah, and then I even heard that um I mean I don't even know how it's possible, but like if it rains, supposedly I heard that fresh water will float in the ocean. Um I don't even think that's true though. But you know, I think it was a movie that I was watching, um, where these people were stranded and they couldn't drink the water, but they later figured out that the top layer of the water was fresh water, and if they would have known that, a lot of them would have survived, but they didn't know that. Um, but I forgot if it depends on the season or a certain time of the day or at night. Um, but I mean, these were probably like I'm thinking like World War II soldiers. But I could be wrong. Um, but anyway, because we all know that fresh water will get contaminated with the salt water, right? But I forgot. Like when they said it made sense, and then they went off to talk about other things like food and stuff like that. The best time to search for food in case you ever get stranded in the ocean, like on a piece of driftwood or something like that. Anyways, so right here we have low solidity surface mixed layer, and then we have the cold hollow line layer, and then Atlantic water. I don't know. This is weird. Um, Brackish water, brine water, saline water. Whoa, hold on. Look at this. Oh yeah, right here. Freshwater halocline, whatever this is, halocline. And then we have well, salt water. Salinity influences ocean water layering. So let me try to, kind of copy these keywords so I could, hopefully get a graph or something or a list. So, salinity, ocean, salinity, water layering. images. Oh yeah, and then I said that we were going to look for some type of um, list or something like that. Look at this. Now this is interesting. There's normal salts, halocline, whatever, high oxygen, normal salinity seawater, bacterial mat, bathtub ring, and then it says high salt up to up to mix something. I can't even read that. And then right here it says no oxygen. And down here it says DHAB water. So there's a point where all the oxygen, you know, um, is removed or depleted, probably due to the pressure of the water or something like that. Because oxygen is like a gas, and just like helium, like a balloon. Well, we have the oxygen, and if we have a helium balloon, it will shoot. It will shoot up to the air, to the sky. It will just like a bubble does in water. A bubble of oxygen. Um, I think it's oxygen. It's not really oxygen though. It's whatever we breathe out. When we go in the water and we breathe out, I think it might be a little bit of oxygen, but even so, in a balloon, helium goes up. Um, so I'm thinking where it gets to the low oxygen level, um, is just because of that pressure, I believe. But there's the bottom. I'm trying to go all the way down where it gets really, really bad, like the solidity. Um, yeah, see, I'm trying to go the depth range, like all the way at the bottom. Okay, like the lowest parts probably. And then, yeah, like it gets all scientific. Look at, like, it literally does. Look at that. I mean, we start talking about percentages, the temperatures, the Celsius or Fahrenheit or whatever, the percentages of salicity, the salts, and other surface layers, other layers, right? And that's what I'm trying to get at. That type of logic, that type of idea, when we're thinking about the black holes. Okay, because I was watching this video, like I said, and I didn't understand what the fucking black hole was. They keep talking about a black hole and a black hole, and that's all they say. They just keep repeating that over and over and over. They keep repeating black hole. They keep repeating black hole. Oh, the black hole. Oh, the black hole. Oh, the black hole did this. Oh, the black hole is traveling in our direction. Oh, the black hole this. Oh, the black hole that. And after a while, I'm just fucking confused. Like, what the fuck are these guys talking about? So, from I don't know if I'm correct, but I heard that this is like the like mass, the weight, kind of like a trampoline. The pressure, not the pressure, but like the weights. But I don't know. Maybe I don't have all my facts straight. I'm still learning about this stuff. Not a lot. Like I'm not dedicating a lot of time into this, but I honestly was surprised to hear that a black hole, you know, basically swallows other planets, like they stay alive. I don't even think that makes sense, to people. That's not in simplest terms. I think that, oh, this is a good picture of it, of one. Okay, it says a black hole's gravity is so strong that light cannot escape. Okay, so because we're talking about layers, and at this stage, and a lot of us don't understand this because we're talking about you know a completely different like dimension, kind of like we were talking about water. Here's us, we don't live in the water, unless we have a submarine, and over time we we discovered you know what to do to stay alive and what not to do in order to stay alive in a submarine. So similarly, we need to, or scientists and people in space have been experimenting and learning how to stay alive in a spaceship. And this is very important because, I believe that, if we ever encounter one of these things while we are in space, I believe we would be able to escape its gravitational pull or whatever. Because it's only like it's like, and then we would have to get into speed. It's only a certain speed that this is happening. It's a slow, gradual energy suction, and if we are operating outside of that, like where we can zap our way out of that, which I believe is possible, um, then at that point we would understand black holes and how they work on a much greater level. Because like right here, this planet is getting sucked into this black hole. And I think it's like I mean, think about it. This is probably like something so powerful, like a flame, but in space. And it's actually burning everything in here, and it's converting it into gases. And that gas, I mean, I don't know what these tails are, but maybe it's burning it and it feeds on, um, it gets fueled by what it's absorbing, like one specific gas, and then it's releasing another. It's just like us. We breathe in oxygen and we breathe out helium. I think it is. Carbon dioxide. We breathe out carbon dioxide. So that's what I believe is going on here. It's like a log of like a wood log, a wooden log that is caught on fire. It needs Fire needs oxygen in order to um to stay alive, um to stay go for it to continue going, for it to continue burning, to stay alive. But after, I mean, let me see. Fire requires oxygen and whoa and produces carbon dioxide. Fires use this to produce carbon dioxide by adding a single carbon atom from the fire's fuel, wood for instance. Fire does use oxygen when it burns, but it also produces carbon dioxide. An oxygen molecule has two oxygen atoms in it. Fire use Fires use this to produce carbon dioxide by adding a single carbon atom from the fire's fuel. So just like us, it's releasing carbon dioxide. Carbon dioxide. So is it possible that this could be some type of fire, like in space? Like here on Earth we have fires, Earth fire started by a lightning. Okay, right? So, you know, without any human intervention, um, the sky can, lightning can strike the the land and creates carbon um, carbon dioxide for itself in a way. I don't know if that's what is happening, but it's possible. So if it is possible and if that is a fact, then the reason it starts raining and lightning starts coming down is because Earth needs carbon dioxide. And it, like I'm saying, if it's true, if this statement is true, then we can basically create um, we can basically create and control the weather. We can produce, you know, the weather. We can manipulate it. And I know for scientists who study, the planet Mars, this is a huge discovery for them if they didn't already know. Um, but anyways, so and I'm not talking about the black hole stuff. I'm talking about if Earth produces its own lightning strikes, lightning bolts to cause the land to burn up, um, to create carbon dioxide. But that's just a theory of mine that I just, concluded after looking at all this. So anyway, so going back to this black hole, I'm thinking it's some type of like, it's like a living organism, and the only way that it can survive is by eating a certain type of gas or something like that. Because I mean, right here is throwing something out, and it's just like on planet Earth, if helium is trapped in a balloon, and obviously we have to hold it down, you know, we add a weight, something heavy, so that the balloon will float up to the heavens or whatever, right? But if we were to pop that balloon, the helium doesn't just stay in the air. It it gets sent. It travels. I'm probably thinking at the same rate when it's in the balloon, or even faster. Maybe it happens at the speed of light when it's outside of this balloon. So whatever's coming out of these black holes, the the tail things, I'm sure they're called tails. Whatever's throwing out, it's automatically going somewhere. It's just energy, and that energy is going somewhere where um, the laws of space ordain it to go. Just like um, like having a bubbler at the bottom of a fish tank, the bubbles are always going to float up. You know, so in the same way, this stuff here has to go somewhere. I don't know where because I don't study space, but just like I mentioned with the water, the same is true with like wood. If you guys add wood and water, the wood floats above the water. If you guys add, some like a piece of metal, it's going to sink. Um, and that's how there's different layering as well when it comes to when with for refining um metal metals. High level process metal refining processes. There's gold mine, gold door, melt, assay, chlorine refining. Um, Let me see here. Mm. It's showing battery stuff. Okay, right here. What the hell? Yeah, so there's different layers in Celsius here. This particular graph, it's basically it's what I'm trying to say is a refinery, and has different layers. This is a Tantalium Wikipedia, some type of earth elements. Different layering for refining metals. Different layering for dividing. dividing. Good night, Mom. I did. No. He's working. Products made from a barrel of crude oil. There's gasoline, diesel fuel, and heating oil. Other products: jet fuel, liquefied petroleum, asphalt. Probably to cap it off. Um, I can also look for different melting points. Melting. Okay, so here it's not in order though, but we have a list, some type of list here. See, this is 271, and then over here we have. Oh no! Oh shoot! I actually clicked on it. Hold on, give me a minute. Um, these people, they just want to keep mocking me. They want to copy everything I say. They're over there, acting stupid. Um, um, guys, look at me, I'm funny. Um, um, I can hear them. They think everything's a joke. So life hits them like a brick to the fucking face. Or when they're traveling at 65 miles per hour and they come to a complete stop. And they'll be laughing in the spirit. Like, ha ha ha. I just died. I just died, guys. Like, yes, you did, you stupid bitch. Yes, you did, you stupid motherfucker. That's why there's laws. Don't speed. Is melting temperatures of common metals. This is what the fuck I was referring to. Okay, right here we have something that melts instantly at the lowest temperature, and then it goes to the highest. That's how these things are organized, these metals. And all of these are, I believe, in the periodic table. Okay, right here. This is the periodic table, and it's super cool. I mean, we have gold, copper, aluminum, I think neon, the neon's in there, titanium. I believe even oxygen is in here. So gases, lithium, hydrogen. Let me see if I can find oxygen. Yeah, right here. Oxygen, number 8 on the periodic table, right there. Top left, we have oxygen, and then right here we have helium. So I think it's already leveled. It's but I'm surprised that they don't have another thing here that specifies that, because it is true. So something at the very bottom will be found probably down deep in the water, like mercury. Mercury will be at the bottom. Um, so would um, so would ammonia. So yeah, right there. No, I think I'm spelling it wrong. Fuck. My spelling is horrible. Hold on. AMMO. I think I did spell it right. Hmm. But maybe it has a different classification. But I doubt it. Let me type in ammonia in the periodic table. So we have ammonia is NH3, whatever that 3 is. Colorless, pun- pungent gas composed of nitrogen and hydrogen. It is the simplest stable compound of these elements and serves as a starting material for the production of many commercially important nitrogen compounds. So maybe nitrogen, but no, it said it right there. And let me see. Let me just copy this because that's exactly what I'm looking for. NH right here, probably. So, um, so this is hydrogen, which is on the same level as helium. Um, sulfur, I don't know how to spell it either, or either. I know some people are very picky with their English grammar and stuff like that. Sulfur, sulfur in the periodic table. Sulfur is the 16th element on the periodic table. So let's go back to the periodic table. Right there, sulfur. Oh, but I didn't spell it right. That's why. So sulfur is below oxygen, which is true. So this, if I'm not mistaken, this goes down deep, like into the earth. So it should have a scale on the left hand side, and it should have oh my god, let me see how can I'm just going to make a quick notes. It's going to be a graph on the left hand side to illustrate to people easily in simplest terms the layering of these raw elements um, according to their proper layering. And we know, for instance, we know that helium is lighter than oxygen. Oxygen is below helium. And if I'm right, then that means that helium and hydrogen are pretty much equal to each other, and their hydrogen and helium are above oxygen, and oxygen is below those two. So that's a quick note. If anyone is interested and wants to bring this up and wants me to elaborate further and maybe even draw out the the side graph or whatever. But um, anyways, I'm pretty much getting distracted here, so I'm going to continue with my video. So for some reason, I was looking for, I think, oxygen. Oh god. Melting temperatures of common metals. We have aluminum, brass, aluminum, bronze, and that's a mixture. So there's aluminum, but this is aluminum plus bronze. So it's a mixture, I believe. So therefore, it requires a higher melting point. Now, oh my god, like I don't know if aluminum bronze, like if it's in a brick, kind of like something solid, and it's in it was placed in an oven at 660 Celsius or 1,220 Fahrenheit, if it will actually etch away some of the aluminum that might not be um, properly mixed with the rest of the brick that's composed of aluminum bronze. But if it's a mixture that is, blended, 50-50, and evenly, then yeah, there won't be any etching, and it would have to reach this point, this temperature to melt this. It says alloys because it has this asterisk right here. right there, that asterisk, that means that there's more information at the bottom. And right here, you guys can see it. In case you guys didn't know, the asterisk is right there. And it has it in red. It says alloys have more than one element, right? So there's a mixture. Therefore, their melting temperature is a range that is dependent on the alloy composition. And I'm not going to elaborate further regarding all of that because I could take the time to um, get into that, but I'm not. But anyways, I just wanted to show you guys the levels. That's all. There's aluminum, brass, chromium, copper, gold, cast iron, lead, molybdenum, nickel, platinum, silver, titanium, tungsten, zinc, just to name a few. And this was from metalsupermarkets.com where I gathered this information, but technically I gathered it from Google because that's what I'm using. But this this what was it? This picture? No, it was another picture. But anyway, something led me to that website, and I don't want to take the time to figure that out. But I just started giving them credit. So, anyways, if I'm right, it would be like the sun, like Earth's sun, getting so close to planet Earth. I don't think that it would just, like, a lot of people think that it will burn, like just the land. But I believe if it got so close to the Earth, it will start to do this type of effect right here. This will be like the sun, and this will be planet Earth, and all the moisture and everything. I don't know if it will go towards it or if it will be repelled. I don't know if it will be attracted to the heat or repelled. I believe it's going to get repelled now that I think about it. Right? Um, so whatever's going on here with this black hole, it's it's like an element. It has like they say here, it's gravity. a black hole's gravity is so strong that light cannot escape. Something is forcing that thing to, all of that, to go into it. And then there's like a chemical reaction because it just like disappears, right? And I don't think it grows any bigger, even though it just swallowed a big planet. It's like, eating food, but we don't notice any, um, we don't notice any, visible signs of bloatation, bloating. I don't even know if bloatation is a word, but if it is, you know, we basically won't notice any bloatation because it would require a lot for that to happen. So that means that a lot of this stuff is getting burned out into space. Um, but I'm still trying to figure out what would cause this to go into the black hole. Because, I messed around with a candle before, and a candle, if you guys add candle wax on a flat, smooth, like glass surface, and you guys hold a lighter to the wax, the wax will start to roll away from the heat. So the gravitational pull could be coming from the black hole, we can say, or or it could be coming from the existing gravitational pull within that area or within that space. So maybe the black holes have no um, effect. They're not affected by gravity, and they possess no gravity. And when it gets close to another object, it doesn't repel because of the existing, gravity that it's held within, or the gravity that it's at. It's like that line, the oil and the water, that in between that line, the oil and the water line where they meet. Maybe this, the place where this planet is at, located at, has to do with, has a lot to do with the planet not moving or the star not moving or repelling itself from this black hole. Um, but I could be wrong. I don't know. But anyways, this is technically a part two of this video here, and it's called "How Vast Our Reality Really Is." Okay, I recorded this video talking about space and stuff like that, and I even show a video that I was watching that I shared with everyone that just made me start talking about all this, freely and openly because, if you guys know me already, if I don't share this information, it starts fucking with my mind. So the only reason I'm recording this video is to get this out of my mind. So I won't dwell on it any longer, so I won't think about it any longer. Here on out. So I just want peace of mind. I don't want my mind to be all unorganized and scrambled. I just want, you know, peace. I want, I want, oh, I want, what's it called? I just, yeah, I don't even, I know this is, everything's important. Everything in this life is important. I know I'm not wasting my time. So, anyways, I will share the link or whatever to this video in the comment section on YouTube, and most likely once this video gets uploaded, I'll copy the link to this video that I will be uploading because I'm recording right now, so I obviously can't upload it right now. And whatever I title it, I will also add that in this other video. But other than that, that's all I have for right now. I'm super tired. It's already 12:27 a.m. So I'm going to bed. Everyone have a good night. God bless. And I hope that this information helped out. Over and out.